OK. So this section is all about TLS, where we're finally going to start introducing some cryptography into our networking stack. So here is where we are in the networking stack. Now, you might have noticed we've inserted a new layer that wasn't previously there. So in the original internet, there actually was no cryptography. They didn't design it with security in mind. So the original internet layering was 1, 2, 3, 4, 7. And remember, 5 and 6 are obsolete. However, as the internet grew more popular, people started to realize that security is kind of important. If people are going to use the internet for banking or sending sensitive information, we had better have some form of cryptography. So they had to insert cryptography in there as a new layer. And since 5 and 6 were already taken, we will use something like 4.5. Some people use 6.5. But either way, now we have this really gross numbering. 1, 2, 3, 4, 4.5, 7. It's the weirdest counting ever. But that's what happens when you don't design in security from the start. You get all this weird numbering. Anyway, this is where we are. So what we will do in this section is we will build a protocol that's on top of layer 4 that provides additional security through cryptography. Now, because we're building on layer 4, this means we can rely on all of the things that layer 4 provided for us. In particular, if we choose to use TCP, we get all the benefits of TCP that we can rely on. So for example, when we're doing TLS-related design, we don't have to think about individual packets. Remember, TCP already does that for us. It splits up data into packets. It reassembles the data. It ensures reliability, and that packets arrive in order. So we, as the TLS designers, don't have to worry about any of that stuff. Somebody else already did that for us. That was us last time when we built TCP. So all we have to think about is a byte stream, which is a long imaginary pipe. We feed data into the pipe, and it shows up reliably on the other side. How big is that data? I don't care. What if the data gets dropped? TCP will deal with it. We can just use the byte stream abstraction, and we don't have to think about individual packets. That's the power of the layers of abstraction. Now, TLS will provide a byte stream abstraction to the application. So if you're an application, like you're writing an internet program, whether you use TLS and TCP together, or you just use plain old TCP, in either case, you get the same byte stream abstraction. So we're not changing mindsets here. We're still using byte streams. We're just adding cryptography to secure internet connections. So if you're someone working at layer 7, you can choose to just use TCP by itself, or you can use TLS and TCP together to get the additional cryptography benefits. So that's what the stack looks like with TLS added. And in case you're wondering what the difference was between HTTP and HTTPS, now you know. HTTP works just on top of TCP, and HTTPS works on top of TLS and TCP together. That's why there was a difference. Now you know.